What's up, my pre-calc people? In this video, we're going to go over the answer key to the section over exponent rules in the AP Precalculus Prerequisite Review Worksheet. All right, now all you got to do is access this document completely for free in the Ultimate Review Packet by using the link in the description below. You could proudly try these problems on your own, and then we're going to go over them right now in this video. Let's tackle them right now. The exponent rules that you need to be successful in AP Precalculus are pretty basic. You just basically have to know this first rule, that when you're multiplying two bases that are the same, you add their exponents. So here we have x cubed times x to the fifth. So since we have the same base, both x, we're allowed to add those exponents together. So we get 3 plus 5. So we have a total of x to the eighth. I mean, how simple is that? On this next one here, same thing, same base, both x, add the exponents when you're multiplying. So that's going to be x 4 plus negative 6. That's x raised to negative 2. Now, the other thing you need to know is that we don't like negative exponents. So you got to understand what negative exponents do. They basically move you to the denominator where you can have a positive exponent. So it's going to be 1 over x squared. We don't like leaving negative exponents in our final answer. So there we go. 1 over x squared is our final answer. That rule is pretty basic. X raised to negative n equals 1 over x raised to the positive n. Negative exponents do not make you negative. They make you smaller. All right, now the next rule is when you have a power raised to a power like we see right here. A power raised to a power, you multiply those powers. So we have x squared times x to the sixth. So here's that first x squared right here, and then x squared 3 times is x to the sixth. Then we can use that rule we just worked on where we add the exponents. 2 plus 6 is 8, so we get x raised to the eighth. All right, here we have x cubed times w to the negative 2, all raised to the fourth. So that's basically x cubed w negative 2 4 times. That's going to be x to the 12th, w to the negative 8. Again, we're multiplying 3 times 4 to get 12, negative 2 times 4 to get negative 8. Now, the only thing I got to do is I got to move that w to the denominator because we don't like those negative exponents. So there is our final answer. Now, I want to be very clear here. If we had x plus 4 raised to the third, that does not become x to the third times 4 to the third, or even x to the third plus 4 to the third. No, 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 no. When you have the two terms in there, when you have a binomial, you have to actually multiply that out. X plus 4 times x plus 4 times x plus 4. You have to have a monomial like we see here, one term, then you could use that rule that we just worked on. Please be very careful with that. All right, now we have a little bit more complicated problems. Just want to make sure we take our time. C r squared all cubed, so it's going to be c cubed r to the 6. That 3 goes to the c, that 3 goes to the r squared, but that's 3r squared, which is r to the 6. Then back here we have c the negative 2, r the negative 10. We don't have any exponent up here to deal with. Now we're going to combine the same bases, those bases of c we could add. So we're going to get c to the first, 3 plus negative 2. And for those r's, we're going to add those as well, and we get negative 4. Then we're going to go ahead and say, hey, wait a minute, we don't like that negative exponent, move it to the denominator. Now, in this last problem here, it looks pretty confusing. All different ways you could do this. Now, we are multiplying, so you don't need a constant to multiply. So we can basically extend this to make one giant fraction. So we could work on the numerators, work on the denominators, then work together. We could work on the fraction on the left, the fraction on the right, then kind of combine them. So several different ways here. What I'm going to do is I'm going to first handle that xy to the third. So on top, I have x to the third, y to the fourth, times x to the third, y to the third. I have xy to the third. That's going to be x to the third, y to the third. In the denominator, I have x squared, y to the negative 5, times x to the negative 4, y to the second. So let me clean up the entire numerator here. Let's see here. I have x to the 6th, x to the third, times x to the third, same base, add the exponents. And then I have y to the 7th. 4 plus 3 is 7 there. In the denominator, I'm going to do the same thing with my common bases of those x's. That's going to be x to the negative 2, 2 plus negative 4. And then for the y's, that's going to be a negative 3. Hopefully that makes sense. All right, now I'm going to go ahead and subtract, because when you are dividing, you could subtract. So same base here. We have 6 minus negative 2. It's going to be x to the 8th. Y will be 7 minus negative 3. That's going to be y to the 10th. Makes a lot of sense. You could also, another way of looking at this is say, okay, hey, x to the negative 2, I don't like that negative exponent, move it to the numerator where it becomes x to the positive 2. Then when you already have x to the 6, that's what makes the x to the 8th. Y to the negative 3 denominator can move to the numerator as y to the positive 3. And then there's already y to the 7. Add those and we get y to the 10th. However you want to shake it out, a couple different ways you can do this problem, but final answer is x to the 8th, y to the 10th.